The part one. Now, Mr. Werner has a cup of coffee. Now, he only drinks coffee at a certain temperature, so while he's waiting for it to cool off, he likes to do mathematics. A coffee has an initial temperature of 200 degrees Fahrenheit and is placed in a room that is 70 degrees. Now, we tend to call this the temperature of the surrounding room, or T sub S. The 200 degrees, we call that the initial temperature. 10 minutes. After 10 minutes, the temperature has cooled to 150 degrees. Assume that the temperature decreases according to the law of exponential growth. Find the value for K. Now, K for us is the rate. It's the same thing as R. And write an equation for the temperature of the coffee at time T. Now, for cooling, we have a formula for this. There's a special formula we have to know. And it says this: the temperature of the coffee at any time is given by this: T sub S plus T naught minus T sub S e to the kt, where T is the temperature, T sub S is the room temperature, or the surrounding area, the surrounding temperature, and T naught is the original temperature. Okay? So what we're asked to find is to find the value of K. Now we can do a little bit of a chart here. We're going to do a little chart. We have the temperature at a given time. Now they tell me at T equals 0, the coffee is let's do little t and big T. There we go. At time equals 0, the coffee is 200 degrees. 10 minutes later, it's at 150. Now if I plug in 0 here, that's just going to give me 200. To find K, or the rate, I'm going to use what happens in 10 minutes. So the temperature in 10 minutes is 150 degrees. The temperature of the surrounding medium is 70 degrees. That's the air temperature. The original temperature of the coffee is 200, and we're going to subtract that from, again, the 70, e to the k. Now k is our rate. That's our rate. And we're going to multiply that by 10 minutes. And I'm going to solve this. If I divide, this becomes 80 equals 130 e to the 10k. And we know how to solve this. We divide. We are going to get 8 over 13 equals e to the 10k. Therefore, the natural log of 8 over 13 equals 10k. So k equals the natural log of 8 over 13 over 10. And we just divide. Clear that out. Natural log of 8 divided by 13, divide that by 10, and we get negative 0.049. Now, it should be negative because it is decreasing. Okay? Now it says find the temperature of the coffee after 15 minutes. Well, now I'm going to plug all my formula in. T equals, well, the surrounding medium is 70 degrees, so this is, say, T equals 15. What's the temperature? Plus the original temperature, 200 minus 70, e to the to the negative 0.049 times T. I'm just plugging it into my formula. And I just plug all that stuff in. Very kind of tedious here, so let's do it. This is how we do it. Plug it in the calculator, and that becomes 130 e to the negative 0.049 times 15. And it's going to give me, wow, it's going to be 132.336 degrees Fahrenheit. Perfect for me. So I'm going to have to wait 15 minutes before I drink my coffee. Now, when will it have cooled to 100? Well, that's my capital T. So 100 equals 70 plus 200 minus 70 e to the negative 0.049 t. Now I'm going to solve for t. Subtract 70. 30 equals 130 equal to e to negative 0.049 t. So we're going to get 3 over 13 equals e to the negative 0.049 t. So the natural log of 3 over 13 equals negative 0.049 t. t equals the natural log of 3 over 13 over negative 0.049. Yeah, my hand there the whole way. Sorry about that. That's what it looks like. I type it all in. Natural log 3 over 13, and I divide that by negative 0.049. And we get out 29.925 minutes. So almost a half an hour for it to reach 100 degrees Fahrenheit. Very easy to do. All right. Our last example for part 1 is what we use for chemistry. Now, please don't tell my wife if I do this wrong. All right. A hydrogen ion of a sample of milk was measured to be, I don't know what this means. Somebody will tell me that tomorrow. That'd be great. H plus, whatever that means. 2.0 times 10 to the negative 7th. Find the pH. One place we use logarithms is on a pH scale, measured acidity and base. And there's a formula that we have for that, and the formula is very simple. To get pH, it's the negative log of your hydrogen ion. I'm just teasing. I knew what that meant. See, I'm a smart man some days. Unless I'm wrong, then don't tell me. We just plug this in. Negative log, and we're just going to plug this in. 2.0 times 10 to the negative 7. And I just typed that in my calculator. pH equals negative log 2E, that's our times 10, negative 7. Hit enter, and I get 6.699, which is pretty much near base. All right, so that's the end of part 1. Make sure you look at part 2, and remember we have our test coming up, so you got to start studying that too, okay? Thank you. Bye-bye.